Welcome everybody. Thank you very much for taking time. Sorry about last Thursday afternoon. Just technical issues just seemed to trip us up. So today we're going to have a go at giving you some sort of insights into some interesting problems. Some of you might have seen, some may not, and the art of structural repairs. There's a little bit goes with making sure that the aesthetics are right. You're not using too much of something. You're bringing all the nuances of the building into the way that you repair. So those are the sorts of things I'm going to through today. A little bit for those who don't know us. Rosemary introduced what we do. You'll see from the group that we do specialise in structural repairs of anything. It doesn't have to be houses, it can be anything through to bridges, and all sorts of commercial things. And within that, we've got various divisions. So we do deal with insurers, that side of it, structural repairs. Underpinning, as I said, we use our Reinforce system, side of things. And we'll deal with anything, really, right up to big commercial structures.
David, can I just actually just come a bit closer? It's the voice, the sound is a little bit breaking up, quite hard to hear.
Well, that's really interesting.
Now that's a lot better there.
Well, I don't know whether it's picking me up from the microphone on my computer or not. Is that better?
That's a little bit better, yeah. It's just as you were further back, it was just a bit hard to
right, okay. Oh, thank you very much, Rosemary. I'll try and keep up the volume.
Okay, sorry to interrupt.
Yeah, is that okay? Or is that still going in and out?
No, that is better. Yeah, it was just I think you were just a bit too far away. I think it wasn't quite picking you up.
It should be picking me up from my microphone though, which is on a headset. So I'm a bit baffled about that. Hopefully that's okay for everybody.
That is a bit clearer. Thank you. Yes.
Great stuff. So Goldhawk bridge restoration ties in nicely because actually we carry out masonry arch strengthening. So everything from the small vaults you find under houses, commercial buildings, right the way up to highways, structures for few innovations. That's our R&D intellectual rights company that basically does all the research into ground improvement and then feeds that back to stress. So we kind of cover quite a few bits and pieces. Here's our services. I've kind of been through most of those, but we do love unusual, awkward and high value projects. So anything weird, we're very keen to have a look at it. We are.
David, I think it might be better if you take that off. I don't think there's any. It seems to be cutting in and out a little bit. I'm just concerned people can't hear you.
Okay, I'll try taking this off and see if the microphone picks up. Right, I don't know, can there be a sort of a thumbs up as to whether that's working okay?
It's a little bit better. I wonder if you just need to be a bit closer to the computer maybe. Are you on computer or? Are
we getting me coming through? I can't tell.
It is coming through, yes, thank you.
Okay, all right, well, lovely. Do you know what? It's only Zoom that has these technical faults. We do, sort of 2 or 3 team meetings a week and obviously team presentations. Never seem to have this problem. But anyway, I really apologise about that. So hopefully caught up on what we were talking about earlier on. Yeah, we're members of the Association of Underpinning Contractors, so that's where we get kind of our sort of accreditation for doing underpinning, but we deal with a lot of heritage buildings, as you will see fairly shortly. Oh, terrific. So now I can change. Oh, Rosemary, we're getting another technical problem now, and I can't move the oh, there we go. Right. Okay. So within structural repairs, you will have all come across masonry reinforcement, very, very useful for all types of things. Crack bonding, we'll use those. Cosmetic refurbishment, I'm going to touch on this a fair bit today. And when we're dealing with historic buildings, obviously there's lots of stone repairs to do. So those are it's really important to get the aesthetics of those carried out. And we provide guarantees with everything we do. So let's get cracking. This is what a lot of you will come across in terms of building disturbance. There's usually a pretty good reason for it. Quite often it's subsidence, and that can be caused by clay shrinkage. It can be caused by consolidation of bills that aren't capable of taking building loads, and of course washout. So you get drains that will burst with time. You get washout of the soils, and obviously then parts of that supporting footing will then actually settle into. So,
David, is it possible you can actually sit in front of the screen? Because I think the further you move back in the room, it's harder to hear. I'm getting a lot of comments on the thing, and it's actually quite hard to hear you.
Right. Okay. As I say,
sorry, it's just.
Is that better?
That's a lot better. Yes, thank you.
But normally use these. I always use the headset. Fine. Okay. Sorry, guys.
Okay, we're on now. So I'll keep starting to.
We've found a crack in the wall. Find the reason for it, and then you've got a much better way of actually then putting in a permanent repair. So find the cause of the cracking. And as we can see here, it's some fairly enthusiastic parking that's caused some damage to this particular house. I put that up for two reasons. One, it's quite amusing. Two, we do get an inordinate amount of call from insurers to pull cars out of buildings. And of course, you can't just literally put a tow hitch on the back of that car and pull it out of the building, because you don't really know what other structural damage has been done. So you've got to establish how you're going to put some temporary works in, temporary measures to prevent additional collapse. And then when you're happy that nothing more is going to get damaged, you pull the car out. So that's understanding the problem. Yeah. We're going to go ahead with some structural repairs to the building. So sorts of things to look at are the building itself. Understand it. Have a look at it. You might have terracotta tiles on the outside. You might have render. It might be things like very fine pointing. All sorts of things that can really make a difference to how the repair looks at the end of the day. Establish from an engineering point of view just how much disturbance is going to be, what your reinforcement, if you're going to use reinforcement, is going to have to take, and then put the right amount in so that your repair is appropriate, and record those proposals. Fairly straightforward, but a lot of people don't do it. So we're going to run into a little bit of masonry reinforcement. A lot of you will have come across this. It's incredibly useful if it's installed correctly. We've been members of or approved installers for Helifix for at least 15 years, probably nearer 20. And yeah, they're quality products, and they give a very good list of the do's and don'ts in their technical specifications. Top left, for those of you who haven't seen how it's installed, that is a built-in wall chaser, and it very neatly, with the twin blades, takes out the mortar completely from the joint on the right hand. Of course, it'll take the brickwork out as well if you don't handle it correctly, but it's vacuum recovery, so there's no dust. And you will get, I mean, that is actually a chaser actually running, as you can see it there. It's not a photo set up for it. So very, very little dust comes out from it. Excellent bits of kit. lower down is actually fitting stainless steel bar. That actually is something called Betinox, which is made by Halifax. And it's sometimes we use it, it's a ribbed bar rather than a spiral bar that you probably know with Halifax. Chap in the top right, in the yellow jacket, actually that is the general manager of Halifax, who is pretending to gun some mortar into the slot for effect. But basically that's how you do it. You use a hand cartridge like that. It's the simplest, easiest, cheapest way of doing it, and you can get the mortar exactly where you want it. Know your building as your structure, as I said before. Really, really look at it, and don't be afraid to use innovation. If it's a listed building, conservation officer will probably frighten you right from the word go. Don't get worried about it. Use some really interesting ideas to try and get around certain problems. He will listen, or she will listen. And quite often they will take on board what you're saying. They'll never tell you how to do it, but they will accept that you have some techniques that would be advantageous to the structure. And once you've shown them the pros and cons, they will understand and quite often take them on board. And there'll be some examples coming today which will show you just how effective that can be. So let's look at a little bit of aesthetics here. So we've got semi-D, 1936-ish, solid walls. No real other major problems other than a crack shown here. You can see it inside, you can see it outside. But what we've got here, and this is the aesthetics, is rough cast render. And I presume this was put on the building at some point in time, maybe 20, 30, 40 years ago, possibly to hide some other problems. And when it cracks, you get, that sort of fine, relatively fine crack that goes through it. All this occurred because on the left-hand flank wall, as you can see the downpipe. There's one at the back, there's one at the front. When we did the site investigation to check out what was going on, in fact, they had never linked those downpipes with any sort of drainage at all. It just ran into the ground. So along that flank wall, it just been washed out very slowly over quite a few years, and that flank wall had just settled gently. So there we've got the crack. Now we can put Haley bar in that from the outside. Absolutely no problem. It'll work perfectly from a structural point of view, but I guarantee you will never, ever match the texture of the render. No matter how good. I mean, our guys are absolutely brilliant. But it doesn't matter how you do it. They'll think it looks good. The sun will come out, and you'll be able to see these straight lines that run straight across. And so if you were the client, that was your house, it kind of wouldn't be too pleased to see some great big scars running across the front of your house. So what do? Well, we nip inside and you install it from the inside. So what we've got there are two twin bars to create what's called a heli beam. They take a lot more load and a good deal stiffer, distribute the load a lot better than a single bar. Resin inject the crack, replaster on the inside, redecorate. You'll never know those cracks are there. And then you go outside and you do some very careful filling of the crack, sponging in and repainting. And it's not invisible, but it's very difficult to detect. I cycle past this probably once or twice a week, and I always have a look at it to see that, one, there isn't any additional structural issues going on, but two, it just fascinates me to see whether in certain lights you can still see it, and it's pretty good. So that is part of the art of structural repairs. So let's look at something listed. This is an old pub in a place called Haddenham in Oxfordshire. And we were called in by one of the larger contractors in the Oxfordshire area that have a special projects division. deal with some old ancient structures. And they said, could you come and have a look at this? We really want to take this flank wall, this gable wall down, you can see there, because it's in a terrible condition and we can't see any other way of doing it. The conservation officer didn't want to see it removed, and neither did the client, because he saw a potential bill for the rebuild. And of course, you need new footings then and modern standards, all the other bits and pieces. Could we save that wall? Well, you can see the sort of state the building's in. We're now looking up that gable wall. You see the cracks in the chimney. It's in a right state. And of course, the mortar's not brilliant either. So you've really got a pile of bricks there. What can you do with them? Well, in fact, you can tie those in. So we decided that we put forward a scheme, price it, and see how that helped the client. We actually got the job and did some more obviously research into what was what, where was where. And you can see here that on the left there, the back of that gable wall, which is all brickwork. You can see where the flue is, and you can see the left hand as you look from the back of the building, right hand from the front. Flank wall is their exposed stonework. And what you actually realise when you start looking at the building is that that gable wall must have been rebuilt at some point in time, because it's the only non-stone bit of brickwork. I know you can see a little bit of brickwork on that right-hand photo, but in fact that's just an infill for a toilet that's been put at some point in time on a very rickety bit of steelwork, which kind of what we had to do to exchange that. So you can see at some point in time there's a discontinuity, and in fact what they never did was they never bonded the new bit of brickwork in with the stonework. It's just literally a straight joint. So that gable wall has been flapping about in the breeze for the last few probably certainly 100, 150 years, I would imagine. And with the heat from the chimney, the sort of suction you get on a gable, it's stuck over the years. On the right-hand side there, you'll see the building before most of the modernisation was done. And in fact, the client there wants to make a bigger opening and increase the steel. So in fact, by installing masonry reinforcement across that opening, you can actually take out a lot of the temporary works that would be required to support that while you put a longer beam in. It then throws a bit of more load onto the right-hand corner there. So in fact, we ended up underpinning that as well. But those are the sorts of things we get involved with. So as I said, you record things on a sketch, obviously, so that can go over to building control. The client can see it, they can see what's going to happen. And of course, our guys use that on site for guidance for installation. We'd normally do this on CAD. This particular one was a small job that needs to be done quite quickly, and so in fact it was done on the architect's drawing. Very straightforward, and we can see what's needed. And you can actually see there, top right, that discontinuity between the gable wall on the right and the gable wall at the top and the flat wall on the right, the stonework. Now, little tip here, if you are rejoining two walls, maybe it's a rear wall and spine wall, what we often see is people running heavy bar around the inside of the wall, which is not quite right, because if you can imagine, if that gable wall now wanted to move out, all it would need to do, if you were putting the bar around the inside of the corner, would just pull it horizontally, the bar horizontally out of the bed joint. And that's not where its strength is. So you want to actually drill right through to the outside, return the bar on the outside. So when that wall has to or wants to try and move out, it will put the bar in the flank wall under tension rather than under sideways pressure. And you use the tensile capacity of the rebar. So here we go. Why I show you this is because although this has nothing to do with the gable wall, we're also beefing up the rest of the property where there's been structural movement too. And you can see natural stonework, which has relatively good coursing on it, but you still have to follow the bed joint around those stone blocks. If you actually put the wall chaser straight through on an approximate line of the bed joint, you would actually have these two very neat straight lines, which when they're repointed would show up like a sore thumb. So in fact, gently follow the bed joint around the stonework. And this will have to be done quite often by hand chiseling, a little bit of architect sawing works a treat, and generally pulling it out. Lime mortar is not normally an issue. What I don't have, really annoyed, because I am going to try and get back there and take a photograph, is what this looks like now once the pointing is all done, because I think you'll see that you really can't tell where those bars are. So I will add that to later editions of this. So there we are. We've got some of the chases in the wall. The right-hand photograph is the important one, because what I really need to show you here, if you're going to site to do any supervision, got a building any of this is going on with, is to look at the condition of those slots. Because if you leave mortar in, it will be flaky lime mortar, which won't bond to anything very well. Because if you think about it, all it's there for is to divide the bricks, keep them even, and take the compressive load. We're wanting them to take tensile with the reinforcement in, so that if there are any out of phase forces that you get in the brickwork, then you want those forces to be distributed back into the masonry reinforcement so that they don't create a crack. So if you don't bond that reinforcement to the brickwork properly, then you're never going to distribute the load, and you might as well use duct tape, to be honest. So the cleanliness of that cut is incredibly important. You don't leave any mortar in there for the depth of the slot you're cutting to put the reinforcement in. So clean faces, brick to brick, okay? And you wash them out, or you vacuum them first, wash them out, make sure they're really clean, then you prime it, then you put the bar in, and then you go over with the heli bond, okay, which is gunned into the slot. Make sure you get it right to the back, so use a finger trowel, and push it all the way around the bar to protect it, and to create a bond with the rebar. You then leave 10 to 15 mil for matching pointing. So whatever the pointing is that you're doing, whether it's lime, whether it's being pointed over with sand and cement, that's what you match, and you colour match it. And when you're finished, it should be difficult to see where you've been. Right, we're going to change on to something completely different now. I think this is some building that you probably, many of you have been to. It's Brighton Pavilion, or Brighton Royal Pavilion. And we've been helping Brighton Council with a lot of their public buildings and historic buildings for many, many years. And they came to us with a problem with that balcony, the Adelaide balcony. For those of you who've been there and had a cup of tea or a beer from the cafeteria, you will be able to take that out on a sunny day onto that balcony and sit there and enjoy your beverage in the sunshine. But there is or was a problem with that balcony, which I'm going to explain to you now. We're going to do a bit of history as well. George IV, he liked a lovely building and got John Nash to look into taking an old villa that they had on site and turning it into something really quite extraordinary. And John Nash thought, well, there's a commission and a half. So he started looking into some of the more innovative materials around at the time to see whether these would be of any benefit to the architecture of the structure. And so this was early 1800s, And at the end of the 17th century, he'd started to see a chap called William Strutt use it at the flax mill. Now that's something that you guys may have come across as well. It's a museum. You can go and see it still. It's the first of its type in the world, we believe, using cast iron in a commercial building to create space and stability. So that was, as you can see, right at the back end of the 17th century. And it became something that John Nash used a lot. But here you can see the elegance, the space it creates. And of course, John Nash saw this and thought, wow, I can create some big open spaces without walls in the Bright Pavilion if I use cast iron. And what you see at the roof there, at each floor level, are what's called jack arches. These are cast iron beams with brick arches that then carry the load of the floor above. So that is will be a rubble fill concrete floor. So in a building that would have been a mill, you've got far less chance of serious fire because you've got cast iron brickwork, stonework rather than timber. And there's less vibration in the floor, much bigger spaces, nicer place. But there is a problem with cast iron. And as you probably know, if you dropped a piece, it shatters. So you've got brittle failure. And this came to the fore back in the early 2000s with the collapse of a roof supported by cast iron in a Bayswater property. 1 to 24 Hyde Park Gardens, as it was. And engineers obviously started to get fearful of buildings that have cast iron in because it's unpredictable. Why is it unpredictable? Well, you probably know how it's cast. You make a sand mold, usually in the ground, and pour molten cast iron into it, which is great. Absolutely fine, not very different from casting steel. What happens, of course, with the gas bubbles that are in there and the impurities is that whilst it's molten, the gas bubbles will tend to rise to the top and they'll bring the impurities with them. And you get all those impurities in volumes you don't really know, or percentages you don't really know, right on the flange where you're going to need most tensile capacity. There probably weren't standards in those days like we have now, and therefore knowing what tensile capacity those flanges can take is a very difficult thing to establish. And so nobody really considered it. As you can see, probably those are cast iron beams above the casting pit there. And, it's steel. It's fantastic stuff. So, of course, Brighton Royal Pavilion got wind of this and were concerned because they knew they'd got cast iron in various parts of their building. A lot of the stuff inside is not a major issue, but the Adelaide balcony was, because it takes a lot of public. Can take up to a couple of hundred people for weddings, for political bashes, and just generally used as a cafe. So they brought in the team, John Holden Associates, that had looked at the Bayswater collapse to have a look at the Adelaide balcony. And they found that the quality of the cast iron wasn't good. So that meant, basically, with a couple of fairly quick calculations, that the factor of safety on collapse of that balcony was less than 1, therefore had to be shut. So what did the Royal Pavilion do? They popped up some props, which is kind of a very sensible thing to do to keep the cafe going, to keep guests coming through the turnstiles and paying to keep for the upkeep of the house. But this isn't a long-term solution, and so we were brought in to have a look at what potentially we could do to be able to move those props. So the idea being you have to strengthen that balcony in some way, shape, or form. So we looked at the options: do nothing, unacceptable collapse, obviously is a risk, which is not going to be acceptable. Install some secondary beams, so take out the props and actually put some secondary beams in. Pretty easy thing to do, but very invasive. So again, pretty innocent to brighten work. How about using some carbon fibre? You know, we talked about innovation. For those of you who have used this stuff, it is fantastic. Obviously, a lot of bikes and boats and planes, racing cars are made out of this stuff. Fantastic. We use it fairly regularly for strengthening mostly reinforced concrete slabs and beams, but we have used it for timber, and it's an ideal substance. I mean, look how stiff that is. It's incredibly stiff. Yeah, you probably can't see this, but it's a wonderful material. Big problem with with carbon fibre plate is that you need to have it work under tension. Cast iron breaks in a shear capacity, and so it's not really going to work with carbon fibre plate. So we've got to think of another way of doing it. And in fact, somebody had thought of this before. And what you do is you actually strengthen the brick arch to take the load in the opposite direction. It casts load from the balcony above sideways into the cast iron beams. We need it to now span from wall to wall so that it takes load off the cast iron beam, reduces the risk of shear failure. Here we go. We are looking at the sorts of materials that are used for planes, cars, and boats. It's biodirectional fabric. So you've got carbon fibre strands running in both directions. We only want it in one direction because that's where we want the tension to be put into it to supply the load capability of the brickwork. So we actually use a monodirectional fabric or sheet, but it is bonded together with loose weave, as you can see those other little strands. You can see that there, to make sure it doesn't actually just drop apart. It remains as a sheet, and we are going to apply this to the brickwork with an epoxy resin. Colin Thompson Partners did the original design, and our engineers who are CTP, heritage engineers, worked with us on law projects, as you'll see probably later in the day, came up with this design for stabilising but not just stabilising, but strengthening that brickwork and making it span from wall to wall rather than from arch to arch. We priced it, we got the job, and in we went. The level of care that needs to be taken when you're dealing with a listed building, particularly one of this standing, I think it's great on gold star status. It's right at the top, and they are paranoid about dust, water, vibration, fire. So we had to protect it with insurance life with fireproof materials. But what it did at the end of the day, once we ordered it, it gave us a really nice working environment in there to be dealing with the balcony above. So that's the soffit, as you can see, series of curves following the line of the jack arches. And there's the props that we'll put in the engine. So, as you do with all listed buildings, or anything of heritage, mark it down. You've got to record everything that goes on with that structure. So each beam got a number, each jack arch got a number, and everything that happened to that arch beam got recorded. Whatever we found, whatever we did to it, it gets recorded so that you've got the history of the building. And we marked up where we needed to take the render off. Now you saw that it was 200 mil strip plus 50 mil either side to be able to then adhere the carbon fibre sheet to it. And the conservation officer does not want you to remove anything on a building that does not need to come off. So we had to only try and take off the zones that need to be strengthened. So that's what we tend to do. And there you can see the good old Hilti wall chaser again, because it's accurate depth. You can change the depth of cut to within 0.5 millimetre, and it's a very neat cut with vacuum recovery, so there's no dust flying around. And there we are. So there's it. There's the render removed where we wanted it. Well, as you can probably see, there's a little bit more came off than we would have anticipated and the conservation hoped for. But the reason being that, in fact, it had debonded. And that may indicate there've been some additional stresses in the arches, we don't know, but it had debonded. But we still had to leave what remained there. So you can see that biscuit on the left-hand side there, in that left-hand arch remaining. We've got to work around that match to it. So we've now got exposed brickwork. For those of you who haven't used carbon fibre before, the secret of it is the bond between it and the substrate you're putting it onto. Because if you don't get the bond, you're not going to transfer the load into the bar. A bit like we said with the heavy bar, you don't actually get the physical bond, it won't distribute the load. You might as well just use duct tape. So we've got to prepare the surface, and we've got to make sure that it, as a surface, has enough strength in it to be able to transfer that load through the epoxy into the carbon fibre. So we cleaned it all up. We then carried out some pull-off tests. This is standard for every job, and you dot around, have a look at various parts of it just to make sure that you're getting that pull-off strength. In this case, obviously, you're testing the surface of the brickwork to see whether it will actually take the sort of bond strength required. So for those of you who don't know, you may not, the minimum bond strength you need to fully mobilize the carbon fibre is 1.25 newtons per millimetre square. Won't mean a huge amount, but that's what you require. So you put these little 50 mil diameter dollies on, you glue them on the surface, you let the glue go off, and then you try pulling them off, and you record the level of force required to pull them off, and that gives you your bond strength. In this case, in brickwork, even though we were really expecting something lower, we got nothing lower than about 2.5 newtons per millimetre squared, which is well in excess of what we need. So that was very reassuring. But before we started actually putting the carbon fibre sheet up, we jacked a little bit of load out of the balcony. So you can imagine the balcony under load, it will actually, by a few millimetres, depress in the middle, even though those beams are incredibly stiff. So we only jacked 8 kilonewtons, 0.8 of a ton out of each one, but we did every single one and maintained that through the application of the carbon fibre. That is our actual conservation manager, Annie, who oversaw the whole of the works on this particular project and to make sure that she was happy for the right load had gone into each one, so she volunteered to do the jacking. Once we got to that stage, we then cut the sheets. Normally, we try and get sheets the right width, but in this particular case, we had to use 500 mil wide rolls and cut them into 200 strips, fairly straightforward. So here we go. We've now got ourselves ready, or nearly ready, to apply. You need that uniform surface. So what you will notice if you put a straight edge up, even to that brickwork, is that little bits of mortar stick out, bricks slightly different angle to another one. And if you applied the carbon fibre sheet to that brickwork, you'll end up with little sort of air holes, little areas that aren't fully bonded. And of course, if you're not fully bonding the whole area, you're reducing the capacity of the carbon fibre to do the job. Therefore, it's really important to make sure you've got 100% bond from brickwork to carbon fibre. So you prime that surface, and then you actually put up a regulating course. Now, for those of you who tried plastering, you know how difficult it is. This is epoxy putty or epoxy mortar. It's about 15 times, if not 20 times harder to apply. It sticks or fine, but to smooth it out, get a really good smooth surface to it, particularly curved, is not difficult. John here, he's worked for us for about 25 years as a master plasterer and master screeder. He made it sticky easy. So there we go. So we've now got this nice smooth surface which we can adhere the carbon fibre to. And as you will see from that little table on the left, we are actually going to install 21 sheets of carbon fibre. Okay, and why we didn't do it 777, I've got absolutely no idea. But the idea being that you do it in numbers is that you're not then hanging 9 uncured layers of carbon fibre sheet onto that first bond layer, because obviously it's going to try and gravity is going to try and pull it off the surface as the resin cures. You don't want it to do that, so you keep the amount of volume and weight to a minimum, and 9 sheets was safely fine to do. So we did it in 993. Here we are applying the roll, so it's all wet on wet. So you go up with your carbon fibre, your resin, very bad like wallpaper pasting. Up goes the sheet, and then you pull that resin right the way through the sheet. Push the sheet up to the next layer. We used blue for some reason. It was really so that we could see where it was going, and you go sheet on sheet on sheet until you've got all 20 sheets. There it is. Next phase, once it's all cured, is to put the render back. Now, we always sample any render, any mortar, so that we can match it. And it goes off for analysis and comes back with a mix. Believe it or not, when this came back, we couldn't believe it, but in fact it was sand and cement. So we don't know when it was done. There was no record of when it was done with sand and cement. We imagined it would be alive. So we've got to go back with the same mix, but we were allowed to put some SBR in it. The SBR just makes it slightly more usable, stickier, and will bond better to the substrate. So you put up your wearing course, and then you finish it. And I think you can see that that's all hand applied. That is quite a phenomenal finish to it, and there you see it completed. So we now have a balcony, or Royal Pavilion do, with a factor of safety well in excess of 2. They're very happy and jumping all around on the balcony. So you're safe. So the heritage works, we work all over the country. So wherever you are, you guys, we'll certainly be very happy to help out with any heritage building. So let's look at something a little bit more different, but it's back to brickwork. And we are looking at a very beautiful structure on the Isle of Wight called Abbey, Q-U-A-R-R. Abbey, Benedictine monks built it back in the early 1900s, came across from France, found this site, erected this really very elegant. I don't know who the architect was, but hats off. It was fantastic. However, in recent years, they found cracks appearing in a lot of the arches in this building. Some form of subsidence. And why it's happened now, yes, there are trees around. We've had a look. we can't really see why the clay has started to consolidate, but it has, and it's caused this cracking. Problem is, in the meantime, you've got the danger of brickwork dropping out in a public area, because you are allowed to go into this. They've got monks praying. They really wanted to make sure they could contain access while there's safe passage through under the arch. And so we were involved in designing and installing a system which would distribute load around those arches, strengthening cracking, and preventing masonry dropping out. So we did that over a period of about 2 months, just approaching the cracks. We had to use a tower because they had to maintain access. So it's 12 meters to those crowns. So it was an awkward job to do, but very satisfying. And we had to obviously colour match mortar. You can see the sort of cracks happening even in the crypt. These are obviously a much lower ceiling, but when you get movement like that, it's very difficult. You can't just patch that in. So in fact, we ended up doing some partial rebuild of these arches sitting right, but we incorporated masonry into that and some plates again to make sure that we couldn't get, because movement is going to continue to happen. There's nothing happening at the moment with rehabilitation of foundations, so there is some still slow movement happening, and they wanted to make sure that cracking wasn't going to cause a problem. Here's a bit of a picture of it. Now here's an interesting one. For those of you who've been to Bath, probably to the Roman baths, we're going to show you a problem with a stroke right alongside it. We were called in by Bath Ness, as they're known, Bath and North East Somerset, which is the local authority that look after the town, or the city, as it should be called. It's got a cathedral, and they called us in to look at a problem with York Street. Now, York Street is that street you can see running away from you under the arch, and where those ladies are walking is the wall that divides it from the Roman baths. So if you climbed up onto that wall and looked over, you would look down into the main exhibit of the external Roman bath. So that all seems fine, doesn't it, really? But York Street is actually a construction done by the Victorians, where they raised a lot of the road levels in York above the old Roman road level, or Roman pavement level. And to do that, they put them on composite steel beams and concrete jack arches again. So what's happened with time is corrosion has had a go at those steel beams and reduced the factor of safety again to something unacceptable for certainly lorries, delivery lorries to go over safely. And so we were called in to see how we could potentially strengthen those beams without, or with the constraints that go with York. The road has actually been shut, and deliveries have to go the way to. That's the main sort of shopping street you can see at the end. This is what it looks like under York Street. So you can see those composite beams running across the street, supported on stonework put up by the Victorians, probably using bits of old Roman ruins that they'd found, bits of old abbey. They didn't really worry too much about the archaeology of it. And what we're looking down onto is actually the Roman pavement. That is the original surface of the Roman pavement. Yes, it's covered in sand to protect it, a layer of sand, but the archaeologists obviously are very keen that no damage occurs to any of the existing Roman remains. So we had to tread very, very carefully. This one. So here we have it in cross section. That is the length of York Street supported on cast iron on these, they're not cast iron, they are steel beams, composite steel beams surrounding concrete. And you probably note that none of them are the same length, and they orientate themselves slightly differently in places too. So a bit of an issue. Also is a problem is just to the north of this page, as you can see it there, 2 semicircles, rectangular cutout, is the Roman bath itself, the main Roman bath. And that is the museum just the other side of that. And they don't want any disturbance, noise, dust, vibration, or pollutants of any sort going through that wall. So that was an issue we had to deal with. And access was a complete no, because we either come through the museum, which would mean potentially working at night and protecting all the glass balustrades and stairs. And even then, it wasn't straightforward running through with beams, heavy duty bits of steel work. So the other alternative was actually to come in through the tradesman's entrance at the back of the museum, which was like going through a maze. So there was no way, I don't think we could even get a sheet of ply around through that. That wasn't going to be an option. So in fact, everything had to come through a manhole from street level. And you'll see why we deal with it, how we deal with it. We had to protect these sort of stylobite bits and pieces that the archaeologists basically threatened us with death, I think, if we disturbed. And bits of old abbey, as you see, have been used there. In fact, we got permission finally to put a deck, a working deck above the Roman road to protect it, and you can see there the sort of conditions that we had to work in. So not only have we got the Roman road beneath us, we've got services running above us, from CCTV to pyrotechnics to drainage, water, gas, fibre optic, and we had to try and work around that. Cable trays, you can see it. What we're looking at there is the composite beams, concrete steel beams, and the concrete jack arches, which obviously you've got holes in them and bits and pieces like that. But we analysed it depth-wise, strength of concrete. It was absolutely fine to take the load, and so there were no issues with that. We just had to deal with the beams. So we had a look to see what sort of corrosion might be going on. So belted away a bit of fairly hard concrete on the outside, Victorian concrete, to expose the steel. Yeah, it was surface, really. The problem was at the bearing ends, which were open. Because you imagine you've got the leakage potentially coming down from the street. You've got the very humid conditions from the natural springs of the baths, and sulfur in that the moisture in the air. It's very corrosive, and so it was the ends of the beams that were considered to be the danger. So what solution did we come up with? Well, you couldn't take great big long steels down there. They had to be fairly lightweight sections, so we went for C sections bolted either side of composite beams through, and as you can see there, there's no two beams of the same length, and we had to do them in sections. We divided each beam into 6 steels, 3 either side. So we had templates made in 2 sets. One stayed on site for drilling, and the second went to the manufacturer of the steelwork, because he's got to put the holes in it and then have it galvanized, so we haven't got a corrosion problem. So we started drilling. There are about 1,500 holes, all got to be in the right place. So we're going through concrete, steel, avoid steel, concrete, which was challenging for the drillers, but they did incredibly well and continued on drilling into it. We took samples of the steel, the record, and as you can see, the web of the steel actually not only in pretty good condition, but actually pretty thick too at 17 millimeters. The system, however, was to put two steel either side of the existing composite steel beams. And what we found was that, in fact, the Victorians didn't really care just how good the surface of that concrete was. So it had to be evened out vertical, so that we had our two C-sections normal to each other. And so we put up guides with a laser detector, and we could then repair the concrete to that exact face, so that you've got a full, good distribution of load from the beam through into the steel. And here we're going up with concrete repair mortar, 40 mm high build, onto the sides of the existing beams. So once we'd done that, it was time to then lower these sections in sequence down through the feet. You can see there, that was our access. In batches, we lowered each and every one of these down onto the scaffolding and into position. And we used very lightweight. The scaffolding couldn't be heavyweight, it has to be lightweight because of the pavement. We used lightweight scissor lifts, and jack scissor lift to lift these things into position, bolt them through, and get them tightened up, and then dry back top and bottom to get them into position. But if you remember that cross section, there was concrete on the outside, two steel beams, and then a void in the middle, because that's the real problem Victorians didn't do. They didn't completely seal those steels in. So we still had a void there. So although the new steels are actually going to take the full load of York Street and can do, it's silly to leave something there that potentially can corrode with time. And so, in fact, we'd already allowed to grout up that void and have holes put in the new beams, so that we can actually get through into that centre area and grout it up. Archaeologists obviously paranoid to spill grout onto the Roman pavement, so kids paddling pools, buckets, and polythene, and all sorts of pieces. And it went very well. Put a huge volume of grouting, but it worked an absolute treat, and there it is finished. And it is actually now a new part of the museum, so you can go down there and look at the archaeological remains, and actually do a bit of digging, do a little bit of archaeology yourself. So that's what you see. And you can take the schools go down there a lot. For those of you near Bath, probably worth a visit if you haven't been there already. But that was very successful. And we are now on a second phase, looking at the corrosion issues in the museum for some of the steel beams. So we're going to change through onto stone culvert. Now, this was brought to us by our insurers, not our insurers, probably insurance companies that we work with, and loss adjusters had worked with us for years, and knew that we solved difficult problems. Now, the problem here was a culvert which was owned by the property owner, and it had collapsed, or partially. That actually is the idiot there. That is the client. We weren't prepared to go in. It just wasn't safe. And I'll tell you why it wasn't safe, because he wasn't, or didn't seem to be too worried that his house sits right over the crown of that culvert. So the back wall of a 3-story, half a metre thick stone old mill house sits right on the crown of that culvert. And he's happily just walking in there and looking to his right to see a void that you could get probably a mini clubman estate in, maybe a beat. It's huge. It's been washed out. It's been the fault of scour from the water running gushing through that culvert and causing scour and erosion of the abutment and then collapse of the arches. We were asked, could we repair? Well, as you know from my introduction, we deal with masonry arches. And the answer was, yeah, we think we can figure out how to do it. But that's kind of what it looked like in cross section. That was the back wall of his house, sitting on a culvert which really had no capacity at all. So the safe system would work. If you work from the outside of the culvert inwards, you can actually put up a prop, a bit like they would do mining, put it on a new pad in the base. So you do a little bit of digging, put a pad down with rapid set concrete, pop a prop on it, something maybe prop with a spreader beam at the top, and you work your way in so that if there is additional collapse, which there could be any time, our guys have a very good chance of being able to get out. That was approved. That's what it looked like a cross section, and we started. But before we did anything under any of it, in fact, I really should have put this section first off. We tied the whole building together so that the front of the building, which is on what is basically rock, wouldn't be pulled with the back if anything happened. So we tied the whole thing together with various straps, anchors, ties, and we monitored that back wall to within an inch of its life. So this was dynamically monitored, so that we had alarms that would go off should there be detection of movement at various targets. But what we also did was reduce the risk of collapse on that back wall by bolting the back wall to a C-section, which ran from stable ground on one side to stable ground on the other. Now, the stable ground, in fact, on the left-hand side here is the road, and the road actually has a culvert underneath it, but it's been reinforced with concrete by the local authority. They didn't do this section because it's not owned by them, and of course it partially collapsed. The stream runs down the hill under that little bridge you can see, through the end of the house there and round past the section of wall above the guy in yellow, and then dog legs under where you see the guys in the and straight under and follows along under the flag wall of the house. So here we are under. We see all the props in place, and we're starting to rebuild it. We had to make sure that scour couldn't happen again, so in fact we put concrete back down, reinforced concrete, to create an abutment, new foundation abutment, onto which we could then start to rebuild all the old brickwork. But if you repair an arch and you just slot bricks in, or blocks of stone, be they bricks or stonework, and you don't create some compression in it, the arch is not going to act as an arch. So in fact, each section had to be put in place and driven so that you create some sort of expansion. You can see good old helibar there, just stitching bits together, gives it a lot of additional initial strength when you're building it. Means you can build it slightly faster. Not easy, not a lot of room to work. And we kept getting floods, so water's still gushing through it, even though we're pushing a lot of the water through by pumps, through pipes to get the water. So here we can see it starting to be closed, and there's it finished. We actually grouted the void under the lounge floor with, I think, about 18 cubic meters of foam concrete. So once we'd finished the arch and it cured, we went up above into the lounge, drilled holes through, and actually then filled up that void with foam concrete. So how are we doing on time? Right, how are we doing, Rosemary? Don't want to overrun people's evenings.
Yeah, we're on 5:10, so we'll probably need to wrap up if possible fairly soon, depending how much more you've got, David.
Well, that's really it. I'm happy to take questions now, if that's okay. And if not, they can go through onto the whatever the recipient is, go through to Matt or Rosemary, and she can pass them on to us, and we can come back to you without any problem at all. I hope that was of interest. Any positive or even negative feedback is always encouraged so that we can improve it. Obviously, don't use Zoom if you can avoid it. Yes, no, very happy to be able to impart some of our knowledge and experience. Again, I hope you found that useful, and please come back to us if you need anything. Any questions?
Yeah, I've got a couple on here. I've got one from someone who's asking if you're removing the lime mortar and replacing with the Helibond, are there any issues with dampness showing on the inside of the low-level walls?
That's a cracking question, actually. Very, very good. Yes, because like sand cement mortar, Helibond is actually waterproof and therefore will trap, in theory, water inside the brickwork and won't allow it to breathe as lime mortar does. We've had a lot of discussions with Heritage Conservation about this, and in fact, what's been agreed and nobody seems to have any problem with is because you're not doing every single bed joint, you're not sealing the wall. And so, in fact, it naturally just breathes either side of the bed joint that has the Helibond in it. But that really is a good question, actually. So you're only probably putting a helibar into every 450, maybe every 300, so every 4 courses. So there's plenty of volume of brickwork to be able to breathe.
Okay. And then the last one I've got here is, are mortar mix samples taken and matched prior to undertaking stitch repair works, both for colour and strength?
They are, and I'm sorry if that didn't come across earlier on. Yes, indeed, we do that for every job we do for colour matching. If it's just a sand and cement pointing that's been put on the outside, then we'd look at that. We'd probably have to match that unless the whole wall is going to be stripped off and redone. But we'd look at the lime mortar behind it and match
Okay, I'm just seeing anything else. A lot saying thank you very much. And one saying, can you provide further example projects of the use of carbon fibre reinforcement? So,
do we have any others?
yeah, example projects of the use of carbon fibre reinforcement.
We do. Not to be able to give now, but
No.
but yes, we do. And as I said earlier on, it tends to be mostly used for strengthening reinforced concrete slabs. Quite often when an opening is going to be put in it. But I mean, we've got an inquiry at the moment, which is for column strengthening. And you can't use carbon fibre plate for column strengthening. Again, you go back to sheet as we were using at Brighton Pavilion, and you wrap the columns, which gives them additional bursting capacity, and therefore they'll take additional vertical load. And so we're looking to wrap the columns, and we've done plenty of those in the past. You can actually use carbon fibre on beams. You can use them on timber beams if you come to it. Difficult to find a timber beam that's actually true enough cut quite often to be able to adhere it properly. But again, we have done it for belfries. You can imagine a timber frame in a belfry. You get weakness in it, possibly a little bit of rot. The amount of work that would have to go into lifting new steels up, timber beams down and new steels up would be colossally disturbing and expensive. And quite often you can then strengthen those beams with carbon fibre.
Lovely, thank you very much indeed. I think I've got one person who's raised their hand. I'm not sure, Mario, if you want to ask your question. You just need to unmute if you are there. No? Okay. Well, lovely. Well, thank you very much indeed, David. Really lovely presentation. It was quite interesting to see all that renovation from someone who's not in that trade at all. Especially Brighton Pavilion. I used to spend many a year there as a student when I was younger.
Oh, there we go.
So, yeah.
Well, very, and thank you for organising it, Rosemary. And as I say, I hope that was useful.
That was very lovely. Thank you very much indeed.
Sorry to just jump in quickly, guys.
If there's anything else we can help with, we did like to.
Yeah.
Who was there? I'll take my leave.
I think it was Mario's question.
Oh, good. Yeah.
Who's asked, does carbon fibre need fire protection? He's put it in his chat. His might not be working, which is why he's put his hand up.
Yes. Again, another cracking question. So, without a doubt, it does, Mario. And what we've got, again, I get measured by our engineers, our design engineers. So for Brighton Pavilion, if you take that one, the carbon fibre is being coated with about 40 millimetres of render. And that's pretty damn good fire protection. So it will give you at least an hour, which you obviously need. If it was carbon fibre plate bonding in a structure with either beams or a reinforced concrete floor, you would probably put there's something called a ProMat board, or they may have come across other things now to do that. It's like a fibre board. We use 40 millimeter ProMat board usually just to coat the beam or the soffit, and that will give you an hour's fire protection. Yeah, absolutely, great question.
Lovely. Well, I think that's it. Nothing else is coming in then, David.
Good. Well, everybody, now enjoy the rest of the evening.
Lovely. Thank you very much indeed.
Thanks, Rosemary. Hopefully speak.
Thank you.
Take care.
And
all.
you.
Thanks.
Bye-bye.
Bye.